Boom, we're here. Good to see you guys. I think we're going to make this the last one before Christmas. So just happy Christmas and you'll have your plans, I'm sure, all made up, and Christmas tree is up already, and everybody's happy, got their presents done.
Yeah, well, I'm not much of a Christmas celebrator, but I do my best.
Me neither, but I have no choice. My daughter's name is Natalia. That means Christmas Day.
Right, okay.
I
Okay.
didn't know that when I came up with the name. I only found out later.
Shot yourself in the foot.
That just means that basically she plays jingle bells on the keyboard year round.
Wow. Okay.
That's the bonus of it. That's it.
Our
Anyway.
tree's still in the shed. It's not up yet.
Say again, Judith.
Our tree is still in the shed. It's not up yet.
Right. What's still in the shed?
The tree.
Oh, the tree. Yes, of course. It's not up yet. Yeah.
We have a neighbour, Pete Boucher, otherwise known as Chainsaw Pete, and he and his son do a lot of chainsaw carvings.
Nice.
And Pete works in the woods, so he supplies everybody up and down our road with trees, Christmas trees, if they want one. So I have no idea where it comes from, and I don't ask.
Sounds dodgy. That's very good. Hey, Doug, good to see you. I was just reading up on changing the subject a little. I was just reading up on the NFU's plans or proposals to reduce the UK's agricultural carbon footprint, and I think they've put about a quarter of that carbon footprint to be stored in the soil. So that's something to latch onto, I think.
Is that enough?
Not in my books, but
No.
it's basically.
We were desperately underwhelmed.
Yeah, exactly. Absolutely underwhelmed. I just don't think we need to send the whole damn lot and the MPs and the MSPs, as far as I'm concerned, in Scotland, on Elaine Ingham's introductory course or something, and see what, I sent a link to one of David Johnson's things to my nephew, who's done agriculture, going to go back home to the farm in the future, but is sitting at home with a broken leg after a rugby accident. So I sent him a link to a David Johnson thing, going on about how much we can increase productivity and production of nutrition using biology and producing better nutrition. I just think these guys that are in decision-making positions have no idea what the potential is. Even if we double it, that's phenomenal.
I think the only way to use it basically is to latch on to the fact that they've got it included in there, and hopefully show better, and then we'll be on the winning side, because they'll sort of understand if we say to them, we're working to help with the goal of storing 9 million tons per year of carbon dioxide in the soil. So they recognize that now because they've put it there. And then hopefully at some point we can basically go like, yeah, we've stored 9 million, we're going to go and store another 9 million next year, kind of thing. So I think this is the only positive I see. This is how I see this.
Yeah, and we've got to show them a few practical examples of where it's worked, how it's worked, and what the quantum has been. Because you multiply up some of the carbon sequestration that we've done, and there are plenty of people who do far better than we do across the country, and it equates to an awful lot more than 9 million tons.
There you go. There you go. That's it. It's like you just gather those examples and off you go to the races, right?
Yeah.
You need to write to your MP and tell him exactly that with all the figures.
Yeah, I mean,
yeah, done that. I haven't had a response.
I just look at the parliamentary recordings, and I just sort of give up before even starting with that idea. So.
Yeah.
I think it can only be done. Sorry, go on. I think it can only be done by community. This carbon sequestration thing, we need to push ahead ourselves and let them catch up. That's what I believe, because they have no practical experience. They don't have the connection to the community. Most of them probably might not even eat nutritional food, you know. So I think personally for me, and as I said, I'm kind of at the start of my journey, and you guys have probably got a lot more experience, but doing Matt Powers' course and learning from Elaine Ingham, this is the only way we can do it. It's the only way, I really believe, and all the stuff that's going to come from this, the community feel, people focusing, the education focusing on nutrition, it can only be good things that come from this.
Have you done the course, John?
I haven't, no. I'm doing Matt Powers' advanced permaculture course. I can't really afford to do Dr. Elaine Ingham's course at the moment because it's quite expensive. But this is something I plan to do kind of early next year. So we're just focusing on following her principles, looking at other people like Dan Ketteridge and John Kempf, and trying to kind of just combine everything together and just test as much as we can. I'm going out doing Korean natural farming, so I'm following Chris Trump, and just practicing as much as I can, basically. But I'm all in on this. I mean, I wake up every morning and just wait for the next thing that I can do just to learn more. So it's just great to be a part of something like this, you know.
Well, keep making more compost then. If you continue doing, you know, what you're doing with at the moment, you know, you'll get to somewhere. So it's good.
Thank you.
Just for the others, you know, John sent us some samples, or your partner, business partner, sent us some samples, and they had some decent numbers. So I don't know if could I have got them.
Well,
I think it was.
What was your compost base, and what were your tricks? Because I need to learn.
Oh, right. So we followed Elaine Ingham's 15-day compost method, but we let it go for a little bit longer just because we were kind of doing it towards the end of this year. So most of the heat had dropped off. And then we added EM. Well, we added biochar. We did it a little bit wrong. We should have added the EM to the biochar and then added the biochar to the compost itself. And then we let it sit there after it had gone through its process. We let it sit there for maybe 6 weeks, something like that. And that's when we took the test and sent it to Daniel. So we're trying to, the next trick is to try and incorporate some indigenous microorganisms into the compost itself, so we can kind of get that biology, especially more, because we want to make it a little bit more fungal, towards the fungal side. So that's what we're going for at the moment.
So basically, you know, in terms of this compost, you know, the markers are that it's an aerobic compost. There's, you know, not an excessive amount of bacteria. There is some fungi showing now. There's, you know, 111. So it's not yet sort of, you know, 1-to-1 like you want for your pasture Judith or anything, but it's a start, right? So it's not, you know, a year-old compost, you know, that's been going. You've got a decent number of amoeba to start, you know, some nutrient cycling, and a decent number of nematodes to start nutrient cycling. So it's a compost, you know, that you can definitely start, you know, working with. And, you know, for your benefit, John, Judith had a very good result by accident once as well, you know. So the thing is that this can come and go kind of thing. So just you need to do as many piles as you can, because, you know, you might have different results from pile to pile, and just don't get discouraged because, you know, one pile is going to be worse than other. So that's when you're still making stuff by hand, you know, you will see, well, when you probably doing larger quantity as well, you're going to see variability, but it's just moving sort of this direction of making sure that it's aerobic, and seeing, you know, what works for you in terms of growing out these other groups. So that's basically the summary here.
And do you find give over time, once you've done, I don't know, 12 batches, that you you learn what works for you and you become more consistent in having better stuff? Or
yeah, two dozen batches. Yeah, you get better numbers. I'm not sure if you're going to be that consistent yet, even. I mean, we had 14 static piles last year, just about 20 active piles this year. And we're just basically at the point where, you know, we've got good high numbers relatively from pile to pile, but they still take, you know, a bit of time to mature, to get to those numbers. And then each pile is going to be still a bit different than the other. And, you know, there's still going to be piles that fail from time to time as well. So I'd say, you know, 30 batches, 40 batches, 50 batches, you know, it's
you still really need to test each batch to know what best to use it for or not use it for.
Yeah, I mean, you know, you're still going to get the nutrients most likely. You know, nutrients are always going to be there, but it's but every pile is going to be different in terms of, you know, it's fungi or it's protozoa or it's nematodes. So that's basically where the variability comes from. And so this is why, you know, on our retail goop product, we also put numbers, you know, per batch of what we actually extracted as well. So, you know, and this can be also problematic when we actually sell that to those individual, you know, buyers, because basically, you know, on one batch, we're going to have 700 micrograms of fungi. On another batch, we had 4,000 micrograms of fungi per mil. So, you know, the variability can be quite high still, you know, and it's still a few years, you know, I think from now until we get very good reliability of, you know, of all the numbers of all the microbes that we produce. And so, you know, that's why I'm so happy about, you know, Sheffield University stepping up and potentially giving us some analysis, you know, from their own funds. So there's still a lot of work before we get there, and lots of trials and tests and whatnot. Oh, Phil unmuted.
Yes, sorry, I was just thinking that, am I right in thinking it's slightly different with your group example, but say if you're using on farm your sort of extracts and teas, the more you keep applying those, and if you're harvesting your ingredients from the compost from the farm as well, you should get a better sort of nutrient cycling. You should end up getting more biology coming through into the compost because you've got more biology in the soil. Do you see what I mean?
Say that again, because you've cut out a couple of times, please.
Sorry. So am I right in thinking if you're in a system, say you're a farmer, you're making your own composts with sort of things that you produce on the farm.
Yes.
The more you keep applying extracts and compost teas on the fields to improve your soils, essentially, and if you take some of that produce, if you like, to make the compost, then it should sort of get stronger and stronger the longer you go. Is that right?
That's in theory, yes, because, you know, you've got microbes that enter plants, then you've got microbes that sit on the surface of the plants because you've been spraying with the compost teas. So yeah, because, you know, I've seen, for instance, hay that never had anything applied to it, and that didn't really have much stuff, you know, if you wanted to put it in water and extract anything. But if you had you know, something that has been sprayed, and you take that and put it into an extract, you will probably find something. So compost is as good as the inoculant that you put into it. Mm-hmm. So I'm pretty sure that you're right on that one. Okay,
because I mean that's what I'm hoping, because I mean, well, we were conventional farmers not that long ago, and we're now organic, but my fear is at the moment there's still a bit of a void of biology, so we've got to build that, but it'll take us a bit of time to build that, and then once we've built that, the compost will be better that we make, if you see what I mean.
Yeah, I mean, also individual piles, there's lots you can do to the individual piles to improve that. So you know, you can still go out to your local ecosystem and find, you know, sort of pinches of material to inoculate with diverse microbes, and then, you know, put some additional feeds on the piles to help them grow out, and just give it time as well. So, you know, again, going back to Dr. David Johnson, this is why he suggests just leaving the pile for a year. because you need that time. And, you know, we find that too. You know, I'm a very impatient person, and it's very easy to go with Dr. Ingham's recommendation to say, you know, you can do it in 21 days. But that's just basically finishing the heating element. Actual growing out fungi specifically takes the longest, you know, and then there's other tricks, you know, if you want to boost the population of protozoa or the nematodes and things like that. But fungi take the longest.
Yeah, and in a way,
the point is you can do it within the pile. You know, you don't have to wait for sort of cycling the material through the farm. But I get your point.
Yeah. Okay. Cool. Thank you.
And Michael joined us today as well. This is going to be your
hi guys.
Your partner in crime, Phil. Now, hopefully.
Yeah, partner in crime. That's ominous. We're not going to rob any banks. just to be clear.
Phil, I thought that was part of the application, though.
Yeah, that's
the application.
Did we tick that box?
Yeah, rob a couple of banks.
That's what they say. That's what they say about free money, right? Okay. Stupid jokes.
How's everyone doing?
Yeah, good. I think my advice, Michael, was pretty bad. You sent that picture through, and I said exactly the opposite of Daniel. I'd believe Daniel.
Oh yeah, because Michael, you sent a picture of your surface of your Johnson-Su bioreactor covered in something, and yeah, I mean it does look like mold. It doesn't look like the sort of white rot fungi that sort of just grab stuff and it appears too quickly for that surface. Yeah. So I would say there's some sort of a mold. Again, these things sort of can come and go. They will leave some spores probably in it. You know, how these spores will actually behave later on down the line sort of has more to do with the rest of the community, I think, than the actual spore itself.
No, yeah, there's been an interesting sort of just watching, because we've set up 10 Johnson-Su bioreactors with various different mixes, and yeah, a few of them have that real sort of coating over the top of mold.
You just don't waste time, do you?
Well, this was before it got too cold. I was terrified of the Scottish winter, and then and now I'm getting tired and depressed, and I don't have anything to compost. So sort of twiddling my thumb, waiting for my microscope. So.
Oh yeah, you ordered it. It's coming.
Yeah, it is coming. So yeah.
That's very good.
But when I sent this order off, it was like the microscope, those ice bags, which, you know, definitely say like for hash growers and stuff like that, and Amazon started like promoting like, do you want some grow lamps as well, and some other things. Like, somebody's going to be watching my Amazon now, like, what is this guy up to? Very
good. So yeah, so that's good.
They'll just start watching your electricity bill. If that goes through the roof, they'll know that you're definitely onto something.
Yeah, exactly.
It's yeah, I mean, I don't know who's going to be buying the goop, you know, at that price. So who knows? Some growers have the money on small scale. I'm not gonna sort of be guessing what they're growing. Anyways, Stephen is here. Good to see you.
Good afternoon, everybody.
Good afternoon to you. We were discussing with Phil actually that mycorrhizal inoculant, sort of whether it can come with or without the trichoderma.
What do you think?
Well, we still probably would want to try it without the trichoderma if possible. So if you've got your supplier to sort of be able to just get it before pre-mixing, then we would be more interested in the one with the mix.
Okay, well, then I will work on that basis.
Thank you, sir.
Good to know. I'm just making some notes now.
Yes. You know, I remember speaking with Glyn, and he he has used trichoderma actually to inoculate seeds to promote seed germination successfully. So there is, there is space even, within the soil food community specialists, for trichoderma. I'm not saying no. We just want to try it out without it.
Why would trichoderma sort of make soil germination quicker?
I don't know. This is something that when Glyn arrives on the screen again, we will be able to ask him. But this is what he told me once. So so I'm just going to quote him behind his back. The person that I am.
Seems appropriate.
Yeah.
So yeah, so this is something that I don't have any experience with, so I don't want to speak too much about this.
Would mycorrhizal fungi themselves give you a speedier germination, or would it just once it's germinated? Once it's germinated.
Daniel, you probably know more than me, but my understanding would be that it's once the seed is germinated, it puts its root down and then connects with the mycorrhiza, and you get the benefit for quick establishment. And
the timing is a bit funny, isn't it? It's kind of like which comes first kind of thing.
Yeah, because that's it, as you say, almost the benefit of the mycorrhiza is as soon as the root's formed, and then it kind of helps it from that point on. But yeah,
absolutely.
Okay.
Which is why I say apply so it goes underneath the seed. So the seed, the root goes down and gets to the mycorrhiza early.
That's it. Do you know what sort of equipment that people have used it to achieve something like this?
Well, it does vary, Daniel, but some are just applying it because it goes in solution, so it's sprayed onto a seed bed and then the seed's put in afterwards. Sometimes they even spray it over the top of the seed, but as they do that, it goes underneath as well.
Gotcha. I was speaking with somebody actually the other day, and this was some sort of a Russian producer of mycorrhizal. And she was saying, and don't quote me yet because I have not seen the product, but she was saying
Tatiana,
yes.
Yeah.
She was saying that that their product, basically their application rates produces like half. Written down. How many did she say? Like a really quite a large number of propagules per square meter. So like 50 to or even 500,000 propagules per square meter. Do you know anything about this? Because this sounds more interesting than some of the products on the market with 150 propagules per square meter.
I've not met Tatiana, but I've heard of her, and I've spoken to a colleague, Dominic, I think.
Dominic, yeah, I had Tatiana and Dominic on the same call.
Yeah.
They were more interested sort of, talking to me about how to reduce the volume of composting in my green waste compost. I think they were introduced in the wrong way to me, basically.
Yeah, I think from what I've heard, Tatiana is probably quite a specialist in her field and knows what she's talking about to a point. But some of what I've heard hasn't been very, hasn't filled me with confidence.
Well, these things, these things are difficult until you get the experience. I'm just relaying the fact that that there was a large number sort of quoted, and I'm just curious because she also sort of admitted that it is a challenge sort of from the perspective of having the propagules in soil and actually having the roots reach the propagule before it actually has a chance to actually start growing into the root and all that sort of stuff. So hence the high number of the propagules in the product. I will be interested to see. So I asked her at some point to get me some of the product to try out because because it's it's a challenge. It's a challenge to have something at that sort of density, I think.
Mm-hmm. Yeah.
Anyways,
very interesting. And there are various sources and suppliers of these things around, but they're quite variable supply as well in terms of the form that they're supplied in, how they're produced, etc., etc.
how many species are there on the market? Because there's the glomus genera, and then there's some other ones as well.
There's at least 6 that I'm aware of, but I'm certain there are more than that.
But 6 genera or 6 species of the glomus?
6 different
genera. So like before the species.
Yeah, just let me get my list up and I'll see what I've got. So I've got a list here of 6 glomus species, and then there's 2 rhizophagous species, and an Entrophospora species, a Pycolatus species, and a Scleroderma. And you've got a mixture there of endo and ecto.
Okay.
So there's definitely different genus as well as species.
Okay. I'm just curious.
But there are more than I've listed there, I'm sure.
Next year, basically, I want to experiment more with mycorrhizae, so that's why I'm mentioning this.
But all those species I mentioned, I have got available in one product or another. Some from Europe, some from the UK.
Okay.
What experiments are you looking to do, Daniel? Have you thought that far ahead yet?
Do you know what? I just want to do experiments of growing them out myself.
Yeah.
So, you know, the thing is that I want to get to the point where we've got the next lot of investment, and I can hire some more people as well as, you know, run trials. And if I get that investment, then I can basically get some more space on the farm and set some beds where basically I just inoculate the beds with everything, grow a mixture of, you know, wheat, barley, whatever, oats, anything row croppy style, and just basically put lots of mycorrhiza in there. Get myself an epifluorescent microscope, check the actual population of the roots, by AMF fungi, and then see, you know, what's the success rate basically of growing this stuff out. So this is the simplest way, you know, people grow out mycorrhizal fungi, you know, in organic soil. So we're going to just basically do it in our compost most likely. And there's other ways of doing that in aeroponics and whatnot. Not sure if I'm going to be wanting to be that sophisticated in year one, but I just wanted to see if we can grow our own, because basically I just want to have a reliable source, you know, just of, you know, in my own little production facility, so I can have a more complete product kind of thing. So that's how I see this.
I see it as a fairly key thing going forward, especially with the fact that our soils are so short of fungus.
Do you know what? Fungi is one thing, but the thing that's been really sort of nagging me is the depth of the rooting, and sort of, you know, making sure that we've got we get rid of compaction zones so that plants can actually put the roots down. And then sort of, you know, the mycorrhizal fungi extending that even deeper. I'm kind of, you know, I need to do more trials to really have peace of mind in that regard, because it just really does seem to me that it's going to be the case of a larger root volume for this whole system to work. But don't quote me yet, okay? But this might be the case of simply deepening the soil profile, getting rid of the compaction, allowing the roots to go down so they don't go sideways, and allowing them to go down quicker, with the biology. And that's basically something that's nagging me right now. So so it might be the case of giving plants more volume, not just the fact that there is biology. And that is just based on a little hunch based around the basil plant on my windowsill. Nothing scientific, nothing coming from agriculture. It's just me. So again, don't quote me, because if I've got a little pot like this, and there is really nothing else for the plants to start grabbing from it, and each time I add something, the plant grows, and then basically after a while, the lower leaves start yellowing. This basically points to me that it's not necessarily the biology, it's also actually the volume of the soil that the plant can actually get the nutrients from. So I'm definitely very, very interested in equipment that we'll have to use.
See, I think that what you said is really sensible, and I absolutely agree that soil depth and rooting is crucial. My fear for UK agriculture at the moment is the equipment we use is so detrimental to that whole thing, and so it's so easy to compact our soils with the systems and machines we use. And I mean, that's the trouble. If we just think, well, biology will fix it, it might not be able to fix it using the equipment and rotations that we potentially use. It still might not be enough. As you say, there might be an element of needing to do both.
Yeah, Dr. Ingham is known for saying that, people talk about 1 inch of soil being created over 1,000 years, but we have done it, in 2 weeks, having several inches. But she talks about going downwards, and that's I subscribe to that. And so, she also mentions quite a lot that you're plowing one last time kind of thing. And so, in a pasture situation, obviously the Australians have had the yeoman's plow, which is not really even visible in this country. There's a couple that I know of, and small ones with like 3 to 4 tines only. And then but people do have, obviously they do have all sorts of implements that break down compaction. So it's just a matter of making sure that we can actually inject the biology when that compaction is being broken up, and run trials like that. And I think it's just going to have to be an experiment, like with everything else.
Yeah.
More experiments. This is, it's like I see these meetings basically as there's a lot of webinars on the web where basically people talk about like use this solution, use that solution, use this solution, and yes, that's very good. Watch these ones. There's lots of experience from people around, and what I see this is sort of like I see a group of people that are open to simply saying like, I'm not going to take everything as dogma. Just basically, I'm going to take what's out there and make my own decision, right? And then so if I can show it to my neighbors, and my neighbors will use it, kind of thing.
Yeah. But I think that's it. We just need to start experimenting and with this system, because there's no sort of large scale amount of soil food web experimentation happened at all in the UK, really, is there?
Nope. There was one done on in Somerset on Sophie Alexander's land. If you look up
Innovative Farmers.
Yes, that one.
Yeah.
And that was done in conjunction with Simon Parfy's Biolab, and I think they had Cranfield do PLFA analysis, and it ran for 3 years. And the first one had some good results, but then the second and third one really didn't very much from the control. And so the thing is that I'm sort of questioning the whole trial from the perspective that the biology was done by the university using PLFA, and that's already now been demonstrated by at least 2 different researchers to be completely non-correlated with microscopy.
PLFA, can you?
Phospholipid fatty acids analysis. Phospholipid fatty acid, and this method basically, this is the gold standard in a lot of microbiology testing. So what they say is that phospholipid fatty acids are the substances that make up cell walls, and so they differ between bacteria and fungi, and so they detect, you know, the concentrations of these things to tell you how much fungi and how much bacteria you have. So it could theoretically give you a fungal to bacterial biomass ratio. But again, I at least can send you a link straight away to one paper that shows that there is 0 correlation between microscopy and that. And the problem I see with that is that it's microscopy that's been used to write the tables of succession.
Yeah.
And not PLFA. And so if somebody basically redid all of the studies, you know, of the plant successions, you know, using fungal to bacterial biomass ratio, but using PLFA and have their own numbers, then thank you very much, you know, we'll take that, because then you don't have to do microscopy. You just basically throw it into a solution, and, you know, in a few minutes you're going to have a result. Great. I don't have to stare down the scope. Wonderful. But, you know, it's not happened, and people seem to be ignoring that fact. And I know that it had a bit of an independent verification, again, from Glyn. Again, don't quote me, because, you know, it's just our conversations. And he didn't see much in terms of the biology in the soil. So it's hard to say that any beneficial biology actually got established in these trials. So I don't know. This is the only large-scale trial that we have available, and I'm not sure if I can use it as an example. And then there's Laverstock Park Farm that never actually produced anything in terms of reports, so I can't, you know, refer to that either. So yeah, it's basically on our backs now to show something.
See the innovative farmers one, because I was looking at that and I tried to find out more about that lab, but is that lab going anymore or not?
So Biolab by Simon Parfit, yeah, it's still operational.
Is it?
Niels uses it. I know he's used it recently to get numbers for his found material.
Okay.
So he sent me the report from there. So there's a massive difference between what they found and what we found as well. So, you know, this is the variability between technicians, by the way. It's well worth keeping in mind.
Okay. Is he looking at that through a microscope now, or is that the fatty phospholipid one?
Do you know what? I think that was actually a microscope one, because they still have microscopists. So I think when I was reading it, I think it actually read a. Hold on a second. Maybe I can find it. I'm gonna. I don't know if I can find it.
So is this a thing where if you're sending samples to labs to get analysed to look for microbiology and all the rest of it, that different people in the same labs, or certainly different labs, are going to come up with this different answers?
It is possible.
And you're better to stick with the same analyst the whole time rather than send stuff to one lab one year and another lab the next, because you wouldn't be able to compare any progress.
Do you know what? It's interesting. It's a very good question, because you're better off to sticking to one lab and one technician even.
Yeah. Mm-hmm.
So, you know, it's like if you've got one lab, basically, you know, we see differences between technicians in our lab, and we try to cross-reference. So we have managed to remove a lot of the differences. So, you know, bacterial counts have come out the same. Fungal counts, they're still different, but fungal counts can be very, very variable, even, you know, with one technician. So the thing to remember about microscopy is that you're taking a sample from, say, a compost pile, which is going to be, you know, 5 teaspoons from a whole compost pile. Then you mix that in a bag, and you send that to a lab, and then the lab takes 10 ml out of that, or we take 10 ml out of that. We mix that, you know, with 40 ml of water, or up to 50 ml total, and then we take a drop out of that, a drop, and then we look at that drop, and that's supposed to be now representative of your whole pile. And so let's say basically, you know, you take 2 drops. Is there going to be a difference? And the answer is yes. We see that especially with nematodes. If there is not many nematodes in the pile, then we can take, say, 5 drops, and 3 of them will have nematodes. We'll have 1 nematode each, and 2 of them will have no nematodes, which means that you've got now a 40% chance that the result that you get basically from the assay is that you have no nematodes. And then you've got a 60% chance that the result, if only 1 drop was sort of looked at, right, is that basically you've got adequate amount of nematodes, because having 1 nematode per drop is an adequate number for compost, for instance, or for soil. So this is, you know, and then fungi, you really have to have a decent amount of fungi to be showing that fungi consistently, you know, from sample to sample, from drop to drop. That's, you know, those 2 elements especially are the finickiest, because their distribution is wildly all over the place. And so it's much easier with protozoa and bacteria. Bacteria, you never have a problem with numbers. They don't differ that much. Protozoa, they usually are there. The standard deviation is low. And so, you know, the confidence is high, and so they don't have a problem. Even if you have different technicians, if you have different labs, you can ignore those things. But fungi and nematodes, if you have better numbers of both, then you've got more confidence in between labs and technicians.
That makes the whole thing difficult when
yes,
authorities and funders want to depend entirely on scientific things, and then refuse to advocate a new system of farming without the scientific proof.
Well, you know, we're obviously, I've started to work on
even if it's successful on the ground, they're going to turn around and say, well, we really don't know enough, so no, don't do it. I mean,
but the thing is, it's like with carbon sequestration. You know, at the moment, basically, to be able to have absolute certainty of carbon sequestration in soil, I mean, you're taking course. I mean, Richard should be able to comment on that, because he knows more than I do if he's available. But the thing is, you know, they take pretty large cores from several places in the field, and take all of that material and extract, you know, the actual value, you know, through the loss of ignition, right? So they dry up all of that material, and then they do loss of ignition, and from all of that material, you've got a much better value. Obviously, the only time you have certainty, if you were to take all of your field and burn it all off, and now you know how much carbon you stored, right? So we never know exactly. We can only sort of decide that statistically there is significance. I had this conversation, you know, internally with Tom as well today, that because we can't take the whole field, we can't take the whole compost pile, we can't even take the entire area of the cover slip if we're looking at 400 times magnification. Because of that, we use statistics. And so the more samples you do, and you go across all of these samples, the more confidence you have. Mm-hmm. And that takes time, and that takes money. So the methods that we basically, you know, the microscopy methods, they have been, you know, used for quite a while. What we want to do basically is to be able to, for this to be used by legislators, we need to have a British standard that is backed with some research, right? And the research would be that we take a compost sample, and out of that we take multiple samples. Out of each one of the multiple samples, we will take, 20 different drops. All that is going to be done by 3 different technicians or 4 different technicians across a couple of labs. And then basically we run statistics of what is the probability that taking 1 drop out of a sample gives us a result that we can trust. Now we know that, because this method has been used for, 3 decades, we don't have a problem with the method, but that sort of research has not been done in the UK, and it's hard to find a paper that exactly just describes that. The only paper that is showing something remotely similar was done in 1982 on a very early version of this method. This is something that in 1982 Dr. Ingham basically did with thin agar plates. So they didn't even have a suspension yet. They had agar that they would have to lay down on the slide, cover with a cover slip that was sitting on 2 other cover slips. It was a mess, and they had to go through 20 of those each to be able to pull the statistics out of that. So yeah, it's to have a method that is recognized by legislator. We will have to at some point go through that, and it's not going to be easy and cheap. It's something that we'll have to get funds from somewhere to be able to do that. What we can do is we can say, we can be transparent that we know there are differences between technicians. We know that there are differences between labs, and to be able to be consistent, stick with 1 lab and 1 technician kind of thing. Or learn it yourself, even better. This method, by the way, Dr. Ingham did basically make this method from the perspective of a farmer being able to look at what they've got in their compost and soil. Like literally, you could get yourself a microscope, and instead of thinking, I need to have numbers of everything, and everything recorded in terms of numbers, right? What you could have basically is you could have a microscope and a knowledge of what things look like. And then basically you'll be able to say like, okay, I can see that there's more fungi than I had before because I couldn't see any before. Or I can see, I've got 12 nematodes in a drop, but I didn't see any before. I had only 1. So that's a change. I know what nematodes look like. I can see, there's a root feeder. Okay, I might have to look into that. Why do I have a root feeder there? When you recognize these things, then you're able to just do it yourself in that limited capacity at least. So there's ways of looking at this, but in essence you're right. There are differences. Questions?
When you're making up a Johnson soup, do you use your similar sort of ratios as you would with the Dr. Elaine Ingham compost, or do you put more fungal food in there?
I would say if I was going for a static pile like a Johnson Su, I would go for fungal stuff, and there is a
100%.
Yeah, you could do. I mean, Dr. Johnson even suggests that that if you starve a pile of everything else and of all nitrogen basically, because you're just putting leaves into it, then the azotobacter has to become active to provide nitrogen for the rest of microorganisms, kind of thing. So the free living nitrogen fixers. Now, I have not seen it myself yet. We've not done that sort of analysis, so I can't confirm that personally. So I'm just relaying. But what you also can do is you can try and feed it with other things. There's a mix of things. We're actually looking to make it into our own little mix product. It's something that's going to be, you know, relatively inexpensive as well to add to the compost pile. And some of it is something that Stephen knows a lot about. There's remin that you can use. And there's all sorts of what you call it, seafood shells, anything that's got calcium, chitin, all these things, but hopefully desalinated, and these things basically, you know, are potentially promoters of fungi over the long time. Fungi is very good at capturing calcium. And the other thing is, what we've been seeing that that having primary decomposers, so like at the top of the pile, might be, and this is still just a hunch based on very limited experience, but just having a strong primary decomposer like King Stropharia on the top might be a precursor for metabolites from that fungi, sort of dripping down into the rest of the pile and feeding the secondary and tertiary decomposers.
Okay.
So yeah, you know, if you're just going for fungi, we've also built piles where we took the green waste compost that was freshly made here on site, and we just loaded that into a pile and added our stuff and just set it aside. So there's nothing stopping you from doing stuff like that. We did have a problem, you know, Judith, how I said, you know, weeks ago about sort of using a bulk compost. It's kind of like, you know, it could be a luck of the draw, because we bought a bag of Veolia compost, and we must have bought it at least a month ago. And this thing, we still have a problem with wetting it out. Like, we can't even wet it out, let alone actually have anything grow in it. So the one thing we still haven't done is we've not taken a pile and actually laid it out on the floor and wet it out properly by hand. We just try to wet it out in the bag, but it's nigh impossible to wet it out. It's just all of the organisms just went to sleep at some point and created this waxy substance that makes it hydrophobic. And we can pour as much water as we want on top, and you're going to have an inch of wetted out material that you scoop out, and the rest is dry, dead dry, bone dry, completely. There's nothing. So yeah, going back to that idea basically of taking store-bought compost, it's a luck of the draw, and it's well worth going to the place that you would be buying it from first, seeing, you know, if it's dry or if it's damp. If it's damp, it's fine. If it's dry, it's going to be problematic, I'd say. It's going to take a bit more than just pouring our inoculum into it to grow it out. Just on a side note.
Soak it in, like, steep it in water so that it's actually
almost, yeah.
It's not running through it. It's actually in it for a length of time.
It's quite possible that could be necessary. I mean, it's like working with hay. Hay is like that. You know, hay basically needs a wetting out overnight, really, to be good for working as a compost material, for instance. We find anyway. And this material is like that. It's just very sort of powdery and it's just dry, and it just doesn't want to take moisture. It's been raining here. It's been sitting outside. It's been raining here, and it's still not wetted out.
What material is it, Daniel?
It's compost from Veolia, ProGrow.
Oh, right. So it's green waste compost, basically.
Yeah.
We don't know what's gone into it, but
no. But the thing is that, you know, we've got obviously the green waste compost here on site, but we don't have a problem with the green waste compost on site because it comes to us fresh, and so there's nothing, you know, everything is active inside. You know, there's so much bacteria that we simply apply our nematodes and protozoa, and they grow in it very, very quickly because there's so much food for them, right? So it's just basically, I just wanted to mention that because, especially in the beginning when we started these Wednesday sessions, I said that it might be an idea for farmers, on a budget to get some of our product and put it into store-bought compost. But now that we've, I specifically bought compost from Veolia to try out that assumption, and we're having a ton of trouble with it, I have to say. So I thought, I mentioned that.
Yeah, it's interesting.
Even
sorry, Judith, carry on.
Sorry, our neighbour that does the chainsaw carving and stuff, I mean, his son produces a lot of sawdust.
Oh, yeah.
And puts it in tote bags, and I've actually asked for some of it to mix with some of our stuff, so that's another job, but puts it and stores it all together. And when you go to the tote bags and dig into it, even if, like during the rain we've had at times, you're right, the water only goes in a hand's depth, and then below that it's dry.
It's interesting.
That sawdust itself isn't dry when it goes in the bags, I don't think. But the water doesn't go right down through it. It takes I think it must take a long time for that to happen.
When I first moved into to the building that we occupy, the composting building, that was last year in April. I took on a lot of material and I tried to mix it all at once. And I laid out a 2.5 foot deep layer of material, basically, and I was sort of mixing it. I can't remember what I was using to mix it, but the thing is, it was 2.5 deep, and then I took a hose and I started wetting it out because it wasn't wet. I didn't have any vessels to wet out some of the materials in it, and I would just be sitting there just for half a day, putting water onto it. It was still dry on the inside. It's wetting out some of these materials, can be a challenge. If you've got some of that sawdust, you could, and if you've got some sort of a bucket or an IBC tank or something, you can literally just put it in there for a while for it to sit in it even, and then just, scoop it out, drain it, and use that for compost as well. Like Paul Stammet suggests. So there's some, that's sort of, then, as you said, you sort of just keep it in water kind of thing.
Peat-based composts have the same problem. They dry.
What's that?
Peat-based composts or growing media have the same problem. They dry out. They're very difficult to re-wet. So they use wetting agents, surfactants, reduce the surface tension of the water. I wonder whether that would help or whether that would have detrimental effect to the biology.
What's the Tom? What's the soap that you have used before?
Castile soap.
Castile soap. Does that ring a bell?
Not familiar with that.
No, but it's like a very simple soap that that we have used when we wanted, for instance, to apply oils to play with feeding fungi.
Yes.
So we used Castile soap.
Okay.
So that's inexpensive and pretty simple. So it's not very. It's something that, and you don't have to use a lot of it. Maybe that is a way of doing that. We've not tried it.
Worth a go, isn't it?
On the list of things we've already thought about it.
There you go. He says it's on the list of things to try.
He's ahead of me.
What's the saying? It's like great minds think alike. There you go.
Mm-hmm.
Fools seldom differ. When I say that, my husband always says fools seldom differ.
Fools seldom differ. Okay.
Yeah. So I don't know.
I think I saw it some years ago. There was a worldwide rally of flat earthers, and they held a banner saying that we're not crazy, kind of thing. So it's until it's like it's doing all these trials are necessary so that we don't fool ourselves.
Mm-hmm.
Being an experimental scientist, because these flat earthers, I think there was a Netflix documentary done, and they actually did an experiment, and they proved that the Earth is round, and they couldn't believe it. So
that doesn't surprise me.
It's very important not to fool ourselves. That's very important.
Yes, but there are many who have.
Okay. Any more questions?
Politicians included.
What's that again?
Politicians included.
Politicians included. Don't get me started again.
No, well, I won't start naming them.
Any more questions? All good? Now, do you know what? I'll wish you a happy Christmas. I'll get that next week's off the calendar. I think we can give ourselves a break, and we'll reconvene early next year, and we'll chat some more.
Fine, yeah.
Happy Christmas and then Happy New Year.
Yeah.
Thank you all.
Excellent. Thank you.
See
Happy
you
Christmas
next
to
year.
you all.
Merry Christmas, everyone.
See you later.
Bye.
Bye bye.
Bye.